Well, welcome everyone. Thank you for joining us today. My name is Zach Semke. I'm director of Passive House Accelerator, and we're very excited about today's presentation from Coltraco Ultrasonics. We'll be hearing from Daniel Drobovolsky and Major Bernard Hornung about achieving passive house levels of airtightness with a Portascanner Airtight leak detector. Let's get into the program here. I wanted to also mention that I'll be playing the role of Q&A concierge during today's presentation. So as questions occur to you during the presentation, please type them into chat and we'll be tracking those. And then I'll invite you to unmute yourself. And if you feel comfortable, turn on your camera and ask the question directly of our presenters. So moving on, I would like to introduce John Knapp, who is a co-founder and CEO of Source 2050, to introduce our presenters.
Thanks, Zach. So I'm John Knapp. We've just presented Source 2050 on this accelerator program 2 weeks ago. We were talking about one of the exciting things of building a marketplace for passive house products is discovering really innovative products and bringing them into the market. I'm actually in Las Vegas right now for the International Builders Show. If anybody out there is here or knows someone who's here and would like to meet up, shoot me a note at John@Source 2050. I'd love to say hello. But in the early days of Source 2050, I received an email from Bernard telling me about the Coltraco Portascanner, and I was immediately taken and saw the real advantages that this could present in the passive house environment for pre-certification, for air testing, for potentially doing away with smoke pencils and the other tricks that we use today. So I'm delighted to have them here today to tell you more about it. So without further ado, I'm going to hand it over to Daniel and Bernard.
Thank you very much, and thank you very much for Source 2050 for having us on today. My name's Daniel Drobovolsky. I'm a senior physicist at Coltraco Ultrasonics, and I was the lead developer of the Portascanner Airtight. So I'm going to talk to you today a little bit about the technology, a little bit about how it works, and also some of the applications and case studies that we've done in the past. But first of all, I'll talk about who we are at Coltraco Ultrasonics. So Coltraco Ultrasonics, we're headquartered in London, in England, and we operate across a diverse array of 25 market sectors. As well as the core company itself, we do a lot of work with Durham University, which is where we have our laboratory, which is co-located with the Centre for Advanced Instrumentation, and also our research organizations, the Durham Institute of Research, Development and Invention, and our Center for Underwater Acoustic Analysis. As a company, we're involved in the research, development, design, manufacture, and integration and sustainment of a number of different technologies, which we export all over the world, and of course, in particular to the US, which is one of our most treasured markets. At Durham University, we identify and nurture brilliant minds, creating a unique research environment in a number of different disciplines. We focus primarily in the subjects of physics, mathematics, engineering, and computer science, where we do some more academic research, but also we do a lot more applied research, and our specialities there are in electromagnetism, acoustics, and information engineering. And that, of course, includes ultrasonics. It is this research and manufacturing excellence that makes Coltraco Ultrasonics the partner of choice for customers and distributors in over 120 countries now today. And we believe that this genuine scientific integrity is what enables us to really give genuine value for our customers and to assure the quality of our instruments and systems. Next slide, please. So the built environment, of course, this is the biggest application for our Portascanner Airtight, and I think a growing application, as I'm sure everybody here today will recognize. In particular, we are focused on passive house principles because we think that the passive house movement is one which really is sort of seeing beyond many of the sort of government regulations today, and we think that it's going to be very, very important in achieving net zero for countries across the world. One of the key principles of passive house is that of airtightness. And that's, of course, where Portascanner Airtight comes in. And it's the world's first micro air leak detector, which uses ultrasound only. Why is airtightness important? I'm sure many of you here today will recognize that it's incredibly important for human health, because in order to have proper mechanical ventilation, you need to be in an airtight space, and that enables pathogen-free, pure fresh air, thermal comfort, and decent acoustic insulation too. It's also important for building health, so that you can eliminate mold, rot, infestation, condensation, and ensure watertightness, fire prevention, and suppression. And finally, it's important, of course, for planetary health, to reduce CO2 emissions, both operational and embodied. And in all of these areas within a building, the Portascanner Airtight is a valuable tool to ensure that you have the airtightness required in order to deliver on these three areas. It is a world-first instrument that will identify leak sites with a microscopic level of accuracy, measure and quantify them using sophisticated algorithms, generate a value for the airflow rate through each leak, calculate the building or room's overall air permeability or air changes per hour, and store photographic and quantitative data to generate traceable, exportable reports. Okay, and on this slide, you can see this is an animated sketch of the operation of the device. So you can see here on the left, there's a generator, and on the right, there's a receiver. And you'll hear that beeping. That occurs through headphones, which are attached to the receiver unit. Whenever the wand passes over a leak site, that indication, audible indication, can be heard by the user. And as well as an audible indication, there is a visual indication on the screen. You see that red bar on the touch screen there that will fill up whenever a leak is detected. The principle behind this is that you have what we call the ultrasonic generator, and that transmits ultrasound through the air. Ultrasound is just like ordinary sound. The only difference is that it's at a frequency that's so high that humans can't hear it. That ultrasound propagates through the air and is relatively uninhibited by any air that it passes through. But then as soon as it comes into contact with a physical boundary, that ultrasound is reflected off, and only a negligible, undetectable amount would ever be absorbed or transmit through. The exception to that is if there is an air leak path through that structure. And air leaks as small as 0.06 millimeters in width, which is a tiny, less than 1/100th of an inch, will be picked up by this ultrasonic instrument. The ultrasound then propagates through these air leaks, and it is picked up by the wand and can be measured by the device. Next slide, please. So this slide talks about energy efficiency, and specifically, of course, in the application of passive house. Energy efficient mechanical ventilation and effective air filtration must start with an airtight building, as I alluded to earlier, and controlled air flow within it. Portascanner Airtight, as well as calculating the air permeability, also calculates the air changes per hour of a room. So when you've detected a number of leaks in and out of a room or building, that total airflow can be summated, and from that you can get an idea of how much volume of air is going to move in and out of that room per hour given a certain pressure differential. often the pressure differential that is quoted is 50 pascals, and that's the case for many pressurization tests. But you can edit that figure if you need to in the instrument by going into the settings. Frequent and regular detection, location, and quantification of unwanted air leaks integrated alongside existing airtightness testing equipment ensures the success of building ventilation strategies. You don't want to be in a situation where you're setting up a ventilation system and you don't know actually how much air is going to be moving in and out of the fabric of that room or building, because if that's the case, then your ventilation system may not be working as you expect it to. Testing with Portascanner Airtight is non-invasive and non-disruptive. So whatever your application, including if you're looking at installing ventilation or testing of ventilation systems, you can do that with people remaining in the room so that ordinary activities within the building are not disrupted. Airflow rates can now be accurately checked at every stage of the execution of the building program, from the testing of all precision-made components such as doors and windows in a factory, that's before they're installed, to the assembly and construction of a building on site. Frequent and periodic testing for airtightness and room integrity in a non-pressurized environment assures a pass when pressurization tests for airtightness are conducted. So if you've spotted all the leaks before you conduct a pressurization test and you've undertaken the necessary steps to repair them, then you can be sure that you're not going to continuously fail pressurization tests and have to go through lengthy and costly procedures as a result of that. Save cost in passing the air pressure test, be it the door fan blow test or the pulse test, first time, every time. Additionally, in a retrofit program or where a pressure test has been failed, the instrument will rapidly locate and measure the leaks and quantify the airflow rate through each leak so that an overall air permeability value can be recorded. Next slide, please. This slide talks a little bit about some of the research we undertook when we were developing the technology. We did a number of tests in our in-house laboratory, but we also did some research in collaboration with an independent organization here in the UK, which is called the National Physical Laboratory. It's the foremost institution responsible for measurements and standards in the UK. So it's broadly equivalent to NIST in the US. You can see here there's a photograph of the testing chamber that we used. That it was a hemi-anechoic chamber. And during this testing, we were using a robotic device which was capable of doing motorized alignment measurements to within 5 micrometers. As a result of that, we were able to test a variety of things, including the accuracy of our device in both detecting and quantifying leaks, as well as any uncertainties associated with misalignment. And you can see here, this is an excerpt from the final in-house report. And in this particular test, we tested a number of sizes of leak, all the way from 0.5 millimeters in extent up to 20 millimeters in extent. And we found that the value generated by the Portascanner Airtight differed at most by 5% from the true value. The Portascanner Airtight, as you'll have seen, and you will continue to see in the next slide, consists of a receiver and a generator unit. The receiver unit looks like this. It's got a 7-inch touchscreen, and it's an easy to navigate interface, which takes you through the whole the whole process of testing, from inputting the information about the space that you're testing all the way through to detecting the leaks and quantifying them. And you can see on this screen, there are a number of leaks that have been marked on a set of doors, and those leaks are shown in terms of their leak area, which is the cross-sectional area in square millimeters, and the flow rate through them. Worth noting is that in the settings, you can easily change between metric and imperial systems. So you can either view your results in square inches or in square millimeters, for example. Another capability of the instrument is to automatically generate reports. And this is an example of an early report we did with the Airtightness Testing and Measurement Association in the UK. You can see here we've got an introductory page just telling you about the space that was tested. And then we've got a page which summarizes the total values for the whole space. So we've got the air permeability at the prescribed pressure differential of 50 pascals and the air changes per hour. Then after that, each subsequent page is a particular structure that was tested in the test house in this case. So you can see there was the first one was a door. We've now got a panel, a window, and an area of roofing. All of these were areas where potential leaks were suspected. We were investigating as to whether there were in fact leaks there. And we found, as you can see from the images, numerous leaks in these structures. And all of those leaks are marked on the photographs, which are taken with the unit. So these photographs are generated not through any external device like a mobile phone. It's all within the unit itself. Those photographs are taken, and then the leaks are marked upon them and automatically numbered by the device. And then you can see below these photographs, there is a table, and each leak is associated with a cross-sectional area and the airflow rate through them, which is measured by the device. Then finally, at the bottom, the total sum of the leakage area is determined, as is the airflow rate in total through that structure. Now we're just going to show you a video which will hopefully enlighten you as to exactly how the instrument is used in practice.
In this demonstration video, Angus shall be using the Portascanner Airtight to measure the leaks around an ordinary door. Angus is using a Portascanner Airtight receiver unit with a receiver wand and a small single transducer supported by a tripod stand. Not shown in this video are the headphones and the 3 transducer generator, which may be useful in some applications. To begin the test, Angus presses the full test button and enters in the required information for the structure that he is testing. He then configures the generator with the aid of the tripod stand. The generator is turned on by pressing the on button and placed in an appropriate location, facing the center of the door. The receiver unit is then used to do a quick scan of the door in order to ensure that there is a good coverage of ultrasound. Angus moves the receiver wand around the door's perimeter. He observes the signal indicator to check that the line remains broadly within the green zone. When he is finished, Angus presses Done and closes the door. Angus then takes a photograph of the door, ensuring all of its sides are visible. Now, Angus uses the wand to look for leaks in the door's seal. He is looking for spikes in the signal indicator and will mark a leak when he spots it by touching on the relevant part of the photograph. As you can see, the ultrasound can penetrate at this particular part of the door seal. Angus looks for the spot where the red bar reaches its maximum and touches the corresponding part of the photograph on the screen. Angus now positions the wand as close to the point of maximum signal as he can. He presses the measure button and holds the wand as still as possible while the receiver captures data about the leak. Once the measurement is complete, Angus continues to scan the door, marking and measuring any further leaks that he finds. In this case, Angus has found 2 leaks. He presses the Done button and takes a final measurement for each leak to determine the amplitude of ultrasound incident upon the far side of the door. This is called the open air value. The door is opened, the wand is placed in approximately the location that the leak was detected, and the measure button is pressed. Once Angus has done this for both of the leaks detected, the data for the leak location, sizes, flow rates, and air permeability may be saved by pressing the Save button.
Okay, so I think it's you over to you, Bernard. But that was just as you can see, a brief video describing the operation of the Portascanner Airtight. You will see in a moment a video of it used in a more realistic setting in a passive house, but that was quite sort of an in-depth, almost a how-to video about how to use it in the case of a door. It can be used in non-openable structures for non-openable structures as well. I know there's been a question on that, so maybe I'll answer that later.
Well, Daniel, thank you very much indeed. I'm privileged to address such an erudite audience and to expand upon what my colleague Daniel Dobrovolsky has mentioned regarding this technology and how each one of you can be empowered to hear what others cannot see. Permit me to touch upon human health, planetary health, and building health, and why a micro air leak detector will save you time and money by ensuring that you will pass the mandatory pressure test first time and every time. You'll be able to check for airtightness at every stage of the build program. Human health. COVID-19 has been the first global pandemic in history to have affected the entire world population. The last 3 years have shown that enhancing indoor air quality to be as effective as reducing aerosol transmission of viruses, as vaccinating 50 to 60% of the population. Landlords and business owners are now challenged with optimizing the operational performance of their buildings to the greatest extent possible, in conjunction with the enactment of behavioral change to minimize risk and to give occupants peace of mind. This significant link to cognitive function and risk of disease, historic effects regarding indoor environmental quality have typically focused on volatile organic compounds and particulate matter. However, modern threats have led to a broader focus encompassing humidity, temperature, and lighting, all of which play an important role in determining virus survivability, immune system health, and infection potential. We must not lose sight of the unique nature of buildings. For example, increasing natural ventilation might be a sound strategy for some buildings at certain times of year, but could create poor temperature and humidity in another, leading to reduction in immune system health and overall increase in viral transmission risk. At present, air quality has a direct and wide impact upon society. Understanding how biological contaminants and viruses can rapidly build up indoors in the context of human health and user comfort has become more relevant since the COVID-19 outbreak. To protect health and well-being of the world population, of which 70% spend 90% of their lives in a building. Place people in a poorly ventilated room where coronavirus-containing aerosols are trapped in the air with nowhere to go, and their risk of getting COVID-19 skyrockets. You can decrease the risk by ventilating the room and filtering the viruses from the air, but you must have an airtight building with airtight compartmentation to do this effectively and efficiently. To achieve this with certainty, you must use a micro air leak detector. Planetary health. The construction industry contributes up to 40% of global carbon emissions, and the total area of additional floor space in the world will double in the next 30 years. It is daunting to see how we can affect the industry anytime soon, but we can make a difference with one building, one strategy, passive house, and one choice at a time. The cheapest energy is the energy we do not use. And by improving the insulation, airtightness, and heating and cooling sources of our buildings, we will have warmer or cooler and cleaner places in which to live and work. We're also being kinder to the one planet we all share. And Passive House's exponential growth comes as no surprise. Great design and specifications give us a better quality building with a smaller carbon footprint. However, whilst designing new build is exciting, we must accept that over 80% of the buildings which exist today will still exist in 2050 and well beyond. Much of our work is now going to include retrofit and assessing which buildings must be demolished and those which can be rebuilt, and where retrofits are the better choice. Operational data from occupants will not always be available. Some of these buildings might not be occupied, and the data you need, you're going to have to generate yourself. Your surveys are going to have to be thorough, and the more accurate the data you have access to, the sharper your decisions. Retrofits are challenging, but in a resource-depleted world, where both operational carbon emissions as well as embodied carbon emissions must be reduced, we need to save as many buildings as possible and to explore cost-effective regenerative retrofits. Thermal comfort cannot simply be procured in the form of mechanical equipment alone. This is why the notion of electrify everything is misleading. If your walls and windows are cold, you're going to lose radiant heat and occupants are going to feel cold. 10 years ago, he's probably listening this evening, Alison A. Bayliss II wrote, "Many architects don't get it. They will insist you need more equipment, and the clients don't get it. And since there's always someone who will talk up the comfort potential of a smart thermostat or radiant floor, it is hard to convince people that it really is about their quality of their wall or window. To achieve a low carbon, high comfort building for the same price as a conventional retrofit does mean we must change the way we work. The Portascanner and the Portascanner Airtight can be used as diagnostic instruments to collect critical data in deep retrofits. By conducting regular airtightness checks throughout the build program, you will know what air permeability values you are achieving, and you can approach the pressure test with the confidence of a first-time pass. Many deep retrofits sometimes include as many as 8 to 10 air pressure tests, and the leaks are found by a slow and expensive method of elimination. There is now no need for this. Building health. The definition of a healthy building by the World Health Organization is a space that supports the physical, psychological, and social health and well-being of people. Whilst this is true, there is no mention of the health of the actual building itself. Today, the value of buildings is intrinsically linked to their energy efficiency and actual building health levels. We all understand the former, but only a few understand the latter. The few that do are those who aspire to close the performance gap and who accept that a high level of airtightness, complemented by either controlled passive or mechanical ventilation, or more likely a hybrid solution, is necessary. Some other benefits of well-ventilated airtight buildings include thermal comfort, acoustic insulation, energy efficiency, pest and infestation control, prevention of water ingress, rot, mold, condensation, and dampness, and importantly, achieving fire suppression. Fire prevention in non-occupied buildings, where hypoxic environments can be created and maintained, is becoming relevant too. Since smoke and toxic gases from a fire, which account for most deaths in a fire in a building, have similar sized particles as infectious virus particles, they will follow similar air paths. This connects our early work with the development of the Portascanner Airtight with our competency in fire suppression systems and room integrity, in particular fire doors. Fire doors have a dual purpose. Firstly, as a fire break to stop the spread of flame and to prevent the fire from taking hold. And secondly, as a barrier to stop the lethal toxic products of combustion from killing people. We know that temperature has an influence on how smoke and toxic gases infiltrate through gaps and cracks in a building. And any gaps or cracks around a fire door, particularly in a tall building, or indeed in any other building near to the fire, will permit the lethal products of combustion to flow through the gap or crack and into the air beyond. Some methods of testing fire doors for gaps and cracks are unscientific, rudimentary, and inconsistent. It is generally accepted that to provide the required level of fire resistance, all fire doors should be reinforced with either intumescent strips or cold smoke seals, or a combination of both. The Portascanner Airtight can be used frequently to check the integrity of fire doors and flat entrance doors with minimum disruption to the occupants of the building. Responsible persons can now be compliant in this respect with the Building Safety Act, which recently came into force in the United Kingdom. In summary, the quantification of airflow rates through individual leak sites, as small as those with diameter of 0.5 millimeters, and being able to detect and to locate with microscopic accuracy individual leak sites, as small as those with a diameter of 0.06 millimeters, invisible, are the innovative aspects of the Portascanner Airtight. There is no other commercially available device capable of quantifying the airflow rate from an individual leak site using ultrasound, not requiring any form of pressurization. I've covered a few applications for this invention within the built environment. Checking airtight seals in industry, in our everyday lives, provides more applications. This unique technology empowers trained operators to work smartly and to be better, faster, and cheaper than all their competitors in finding the leak, sealing the leak, and fixing the leak. It is the ideal instrument to ensure that you achieve your desired level of airtightness. Thank you.
Hi, my name is John Knapp. I'm the co-founder of Source 2050. We're here on 25th Street in Manhattan. Great project that's underway. It's a firehouse retrofit to a single-family home. And I'm here looking at the Coltraco Ultrasonic Portascanner today. It's an airtightness detection device that works off of ultrasonic frequencies. We have a transmitter that's just through the window here, which we set outside, that's transmitting ultrasonic waves through the back of this house. And I have here a scanner that's detecting if any of those are getting through the wall. So it allows us to detect whether there's any gaps in the airtightness barrier that need to be remediated. So I've been scanning through with Kevin and found nothing. As we were coming around the door, everything is nice and tight, but I got to this spot right here where I started to see some activity, some red and green popping through the bottom of the meter. So I talked to Kevin. I said, what could that possibly be? And it looks like it's simply that we have some masking tape in here to protect the door frame, and that the gaskets are not thrown on the door, so it's not fully tight. So Kevin tightened up the door. I redetected it. It's airtight. All the entire signal has gone away. So it's a really nice test case of the sensitivity of the meter. But I was talking to Kevin, like, if this had not been that easy to fix, if it had been somewhere else in the attic or something else, how would this been useful to you? And if we detected it in the system, it'd be easy to mark that off and then throw the crew and bring in some foam.
Take a shape, take a Sharpie, mark where it is, and then fix it and tape it.
Great.
Find a leak, seal the leak, fix the leak.
Great, yeah.
And then test it again, make sure it's sealed.
Yeah, exactly, yeah. And you can see that you're able to take a picture of every wall that you scan and then mark it up with where you detected the leaks. And then as they're remediated, you can remove them. As Kevin said, if you've really got your air sealing crew on your elbow, you can also just mark up where it needs to be, and you can do a whole room, and they can come through and then seal where they need to seal. So it's pretty interesting. Instead of walking around with smoke pencils and fog machines and trying to track where things are going, you get a pretty crystal clear image of where there's any weaknesses in the air barrier.
Cool. All right. So hopefully that video cleared a few things up for you. I'm now going to talk about some case studies before we take some questions at the end. So we've got a number of case studies that we've performed over the last year or so. One of our very, very first ones, which was alluded to earlier, was at the Airtightness Testing and Measurement Association in the UK. During this case study, we were testing what's called their Building Performance Hub, which is a small building located within their facility. And we performed this test alongside the pulse test and the door fan blower test. During this test, we were able to identify a number of leaks in windows, roof panels, and door seals, which had not previously been found using traditional methods such as smoke pencils or thermal imagery. Another case study that we performed was in a passive house in Manchester in the UK. During this study, we found in particular substantial air leakage at the bottom of a door, which indicated that there was a crack in the bottom seal. This was confirmed by the site manager, who determined that the door needed a final adjustment in order to be properly airtight. Case study number 3, this was actually in Slovenia in Europe. And this was using the device to test a low energy building. As it is portable and handheld, as you saw from that video, it was easy and efficient to test the building, locating and quantifying leak sites. It identified small leaks in the window seal with the quick test function that was soon sealed. There are a couple of different functions in the instrument, and the quick test is particularly useful if you have somebody readily available to seal those leaks and you're not so interested in quantifying them. You can very, very easily and quickly spot them and then seal them up. Next slide, please. So a few more case studies here. This is actually in a very specific area of healthcare related applications. The first one is quite niche. So it demonstrates the versatility of the instrument. And we've often found customers who purchase the instrument for one particular issue, whether it be because they're not sure that the doors they've ordered are properly airtight, or they're looking for leaks in an area of roofing. And then they find that it can actually be used in so many different areas where airtightness is important. So this first case study involves biological safety cabinets, which are used for the containment of potentially harmful pathogens or chemicals during procedures in healthcare settings, such as blood tests. And these are very important for preventing infection spreading through laboratories and other nasty things like volatile or organic compounds. So we were testing in this environment a class 2 biological safety cabinet, and we were able to use one of our 2 generators. This one was our precision generator, which is ideal for this application because it's very, very small and can easily fit inside the cabinet. Each surface of the cabinet was tested, and significant leakage was detected through the side panel of the cabinet. The leakage was then sealed on both sides with silicone, and retesting the same areas immediately showed substantial improvement in the quality of the seal. So that was able to, first of all, identify the problem, and then to verify that the problem had been solved. Another case study, this time in Hong Kong, was with our exclusive distributor there. The Portascanner Airtight was used in a prefabricated negatively pressurized wardroom, which has been used for during the COVID-19 pandemic to facilitate patients infected with SARS-CoV-19. Leak points were found within the doors in the negatively pressurized wardroom, and the team used the instrument to quantify the leak sites in order to ensure that the negative pressurization system works effectively. So just to recap, Portascanner Airtight can be used regardless of whether or not the facility is currently pressurized. That's because it's detecting potential air leaks, so paths that air can flow through. So the air doesn't actually have to be flowing at the moment that those paths are detected using the instrument. So in this instance, the pressurization facility did not have to be pressurized at that time, but by spotting those leaks early, the team were able to locate where there might be issues that would lead the necessary pressurization of the facility to fail. And ultimately, that negative pressurization within that facility was able to be successful, thereby preventing any infection spread out of it. Finally, we have a case study involving a clean room. Of course, clean rooms, a bit like isolation rooms in healthcare settings, it's very, very important that they have an extremely high level of air tightness. And in this particular clean room, we were focused on 2 main areas. There was the inner entrance door, which of course the seal between the door and the wall is a potential source of leaks. And a subsection of the clean room used for moving equipment in and out without compromising the integrity. The Portascanner Airtight found substantial leakage around the latch on the secondary entrance door to the clean room, as well as across the top and right-hand side of the door to the equipment room. So those were a few case studies for you. I think we're now opening up the floor to any questions.
That's right. Daniel and Bernard, really great presentation, a very interesting device, and you have generated, I think, more questions than we've ever witnessed on a component spotlight, which makes sense with this brand new technology and application to passive house practice. So we are going to get through these as efficiently as we can. For some of you, I think you had a number of questions that you've posed in chat, and what we're going to do, just to be fair to everybody, is to go through kind of in the order received of those questions. So next up then is Enrique Bueno.
Thank you. My question was actually answering the video, but I have another question. How far do you require a certain distance from the wall, exterior wall, for example, that you're testing inside? Is there a limitation on the how close you have to be or how far you have to be?
Yeah, so that's a great question. The answer is we recommend between 0.5 meter and 5 meters back from the wall. So if you've got your generator too close to the wall, then the ultrasound is not going to spread out enough to really cover that area. So especially if you're testing a larger area all at once and you don't want to have to move that generator, then you want to place that fairly far back. It definitely will work up to 5 meters in distance. We also provide, as I mentioned earlier, 2 different generators. One of them is designed to give a larger spread of ultrasound. So you can move that back a fair distance away and ensure a decent coverage. But in situations where you don't have enough room, then using the precision generator about 0.5 meter away will also work. But the important thing is not to have it too close to the wall. If it's just a few inches away, then it's not going to cover a substantial area.
And if you put it 5 meters away from the wall, how much area will you be covering from that wall?
So it's we have a table which we can send you exactly of the relationship, but 5 meters is, broadly speaking, it's about, or let's say 5 feet away. That's broadly going to be about 6 feet in width and 6 feet in height in a circular region. So that should give you an idea.
Okay, thank you.
Thank you, Enrique. All right, next up is David.
Thanks, cool instrument. Question would be the receiver on the videos, it was right up against the surface area. So I'm assuming it has to be as close as possible. And also all your examples were basically fenestration, so single material assemblies. Have you tried it on multi-component assemblies where the air path, the leakage on the inside could be at spot A and the air leakage from the outside could be 10 feet down the wall? How have you done anything like that?
Yeah, absolutely. So I saw a couple of questions about that. So before I answer the question about being convoluted, in terms of the distance of the receiver, in order to properly measure and quantify those leaks, the receiver does need to be held at a set distance. And what we have is a little clip that's provided with the package, and that goes right on the end of the receiver wand to ensure that that is right up against the area that you're testing. But when you're locating the leaks, it's quite a swift procedure. So you're going to be scanning with that wand around, and you'll have the headphones on. So as soon as you hear a bleep, you can then go back to that area and then sort of zone in on the area concerned. So it's fairly quick in order to assess a large area by doing it that way. Now, in terms of convoluted leak paths, I've personally tested it in a few different buildings, and there have been situations where we've thought, okay, there could be a much more complex leak path going on. As you say, if you've got, let's say, 2 kind of outer surfaces and you've got insulation in between, then the air could be leaking in all sorts of directions. And the answer to that is that those can absolutely be detected. You've just got to be a little bit careful about the placement of your generator. So if you've got a situation where on the interior there's a potential leak coming through, let's say below the base of a window, but actually when it goes in towards the insulation, it then comes out at the top of the roof, then you're going to need to make sure that your generator is positioned in such a way that that ultrasound is going to cover that whole surface concerned. As long as the ultrasound can reach a large area from the outside, then that ultrasound is going to penetrate through the outer opening, it's going to bounce around inside, and it's going to make its way through to the inner opening. So if there's no matter how circuitous, if there is a route for air to flow and the ultrasound is positioned, the ultrasonic generator is positioned well, then the ultrasound will be able to get through and you will be able to detect that leak.
Excellent, thank you. Next up is Robert Whitehouse. Robert, I know you have a number of questions. Can you choose one of them for this one?
Yeah, I'd like to know how you do like multi-level buildings. Because if the generator's on the ground floor and you're on the third floor, or how does that work for testing walls and things?
Yes, so of course the generator needs to be on the opposite side to the receiver. So if you've got multiple floors, there are a number of different ways you can approach it. We've done it in the past with scaffolding, and that's obviously a very easy solution. If it's a non-scaffolded building, we've had customers suggesting that they'd actually like to mount it on a drone. That's very much a possibility with our smaller generators. And as well as that, sometimes you might have to get inventive in terms of suspending the generator from a higher floor, or also the generator comes on a stand. Some sort of telescopic rod could also be used in order to position the generator outside, let's say through a window, to then assess another area. But absolutely, it can be a challenge in some multi-level properties if you don't have access to the other side. But if you have, in particular, specific areas of concern, then using other equipment like telescopic poles or suspension could be a way around that.
Great, thank you, Robert. And next up is N.R. Murray, and she is in, I think, New Zealand and has a spotty connection, so has asked me to ask the question, and that is, are there any standards that the Portascanner complies with?
I'll give this over to Bernard. Given that we're quite, obviously this is very new technology, I think standards tend to take a while to catch up, but I'll ask if Bernard knows a little bit more about this subject.
Daniel, thank you very much indeed. I think and I've seen quite a few questions about this. The most important thing here is to recognize that we have an invention. And you have to rely, as Daniel has mentioned, on scientific integrity and the laws of physics. And when you introduce a new invention, it will take time for the regulators to accept and possibly even to understand that it works as it's set out to work. And the reason we're speaking to the Passive House community is because we know that you are passionate about achieving excellence. And we've invented this instrument not to replace the door fan blower test or the pulse test, but to reduce the number of times that you've got to do those tests. So this is an invention which is going to enable you to do a lot of the preparatory work to ensure that you're able to pass the mandatory tests. At the moment, it's still too new for us to have achieved any standardization within the built environment. It is an instrument which derives from technology from the marine industry, and to stop ships from sinking. And it is an invention that has been adapted from technology that we've had since 1987. And therefore, we've got absolute confidence that it will work. But we also must accept that we need to be patient and that we need you and many other thousands of people around the world to use it until such time as the regulators develop standards for it. Thank you.
Thank you, Bernard. I'll just add to that in that, as Bernard's mentioned, there are some technologies such as the door fan blower test, which are well established and have been around for quite a long time, and those are mandated. In time, we do believe that ultrasonic techniques, and in particular the Portascanner Airtight, will be something that's asked for. But in the meantime, we would position it as something that's complementary to those mandated tests. As we say, you don't really want to be in a position where you're having to do 3, 4, 5, 6, 7 different airtight pressurization tests just to pass one building. So the true test of the equipment is whether or not you can use it to detect those leaks, to seal them up, and then to know that you've saved time and effort in doing those pressurization tests.
So after that, we have John Rodenheiser.
Hi there. I think my answer, I got the answer to my question as well. I think it's going to be very difficult to say that a building has a certain ACH without measuring, quantifying every single leak in the building, which would be, and then adding them up. So that might be a little more difficult to try to have that take the place anywhere down the road to determine whether it meets a passive house standard. Just because I can't imagine, one thing about a blower door is it makes this pressure happen on all 6 sides of a building, and it's very difficult for that to be achieved ultrasonically, I think. It'd be great for compartmentalization of an individual unit inside a multifamily building, but you're still really limited to what is the largest wall you can do? What is the surface area of the largest wall?
Yeah, I think it's infinity because you can actually move it around. So John, I do get your point, and I do understand your reservations. You have to believe us that the capabilities of this instrument actually far exceed the door fan blower test or the pulse test. And that will become apparent to you and indeed to everybody else in due course, but it's not going to happen immediately. And you're right to question this, and you're right to make it difficult for us to prove it to you. We have no difficulty with that. We've done sufficient case studies in very difficult situations. We've used it in passive house case studies, and the results have actually even surprised ourselves. So, but definitely as far as compartmentation is concerned, it works extremely well. And certainly as far as inspecting the integrity of fire doors, which is now becoming incredibly important following the Grenfell fire tragedy here in the United Kingdom, and a huge emphasis being placed upon checking fire doors once every 3 months. Well, that's not a practical proposition without an instrument such as the Portascanner Airtight. And I'm confident that there are sufficient applications, not only in the built environment, but also in many other industrial applications, that we're going to have the opportunity to prove to you and to others beyond all reasonable doubt that this scientifically led instrument is far superior to anything else that's available commercially today.
Thank you, Bernard. Just to add to that a little bit, we're not knocking the pressurization test at all and the blower test. I think someone has mentioned in the chat that obviously there are pros and cons of any technology, and the blower test, of course, can stress the building. So in situations where you're worried about increasing the pressurization on a building fabric, this is a useful technology to not have to deal with that. I will also say that if you're trying to find the air changes per hour of a building, room, or compartment, then absolutely, to get a full value of that, you need to spot every single leak in that area. But very easily, you could target a particular area, find that there are a number of substantial leaks there, and already, even from spotting a few leaks, you might then determine that that room or structure fails to meet the air changes per hour requirement because the leaks in that particular area are too large. If you survey an area and you find that there are some leaks, but they're not substantial, then you can continue to perform a test to to understand the total air changes per hour. If there are areas that are less accessible, or you simply don't have enough time to test a whole space, then you can at least extrapolate from the values that you have received in order to produce an estimate of the air changes per hour for the space. So there are a few different ways in which you can use the tool, depending on how much time and the capabilities that you have.
Great, excellent. Thanks, John. Next up is Nick Grant. I know that Nick has had to leave the meeting, and I think that his question, which is about wall assemblies, has probably already been addressed just now. So let's move on to Robert Whitehouse. Robert, do you have another question you'd like to ask?
Yes, I do, actually. Thank you. Is the ultrasound dangerous to the operator with multi-use if they're using it constantly over time?
Yeah, good question. The answer is no. Ultrasound is very much like ordinary sound, just higher frequencies. So if we were dealing with incredibly large amplitudes, then that could damage hearing. But the amplitudes we use are not within that range to have an effect on human health. There are a few studies out there on the health effects of ultrasound. But within the parameters of our equipment, that's generally considered a very safe range. And you can see, of course, ultrasound is widely used in a medical setting, for example, in scanning pregnant women. So it's very much safe.
Great, thank you. So next is David Holtzclaw. Do you have another one?
Yes, thanks, Zach. We use ultrasound to measure thickness of coatings, air barrier coatings, of finishes on fenestrations, paint on bridges that prevent corrosion. And those instruments, not just the amplitude of the signal, but the frequency of the signal is extremely important to make sure as that sound travels through different materials, it gets bounced around a lot. My concern with this instrument, as you go through multi-components assemblies, and you're hitting the signals going through multiple different components, that frequency shift could change and can result in significant error as we see in other devices. Your display just looks like, from what you showed on the video, was just showing the amplitude. Are there any error analysis, signal to noise ratio type of information that instrument provides the user to know when they're getting a good signal or not?
Yeah, so we also manufacture thickness gauges. So I'm familiar with the specifics of ultrasonic thickness gauges. It's a slightly different, the physics behind this is slightly different to ultrasonic thickness gauges, because thickness gauges use ultrasound propagating through a solid, and they use the speed of sound in that solid to determine the time of flight, and therefore the thickness of that particular material. That's not relevant for our technology because we're propagating ultrasound through the air. And we're actually not interested in the speed that ultrasound takes to get through the air. We're just interested in and I won't go into details, of course, but the quantity of ultrasound that gets through. So you're right in inferring that it's something to do with the amplitude more so that we're measuring than the frequency. The frequency we use is 40 kilohertz, and it's quite a narrow band. So as that ultrasound propagates through the air, there won't be any frequency shifts because it's merely traveling through air, and the medium is relatively consistent. What does cause fluctuations in air is if you've got heavy winds, for example, that will affect the strength of the signal. But in our receiver unit, we take 250 different measurements per overall quantification measurement, and that signal is then time averaged over that period. So the ultimate signal that you're receiving is going to be a time average signal, which accounts for any fluctuations in the air that the ultrasound moves through. Hopefully that made sense. I know it's quite a sort of complex subject.
Yeah, so there's no way to see a signal to noise ratio. Is there any way for the user to be confident of the signal? That's kind of my bottom line here.
Yeah. So we've tried to make the interface as kind of foolproof and simple as we can. So we don't have lots of confusing numbers going on. But what you can see in order to kind of assure yourself of the signal to noise ratio would be if you have no ultrasonic source whatsoever and you hold the receiver wand, you will see a very, very small signal being picked up, and that is of course the noise. And then if you compare that to when you do have a full signal generator turned on and you have an ultrasonic signal, and if you just hold that receiver wand pointing at it, you will see a much larger signal being picked up. So you can at least hopefully have some assurance from that if there's no ultrasound around, then the signal is very low, and that's just merely noise. Whereas if there is ultrasound, the signal is much, much larger, and it will be a factor of I'm going to say something like 1,000 times larger than the background noise. That's the maximum amplitude that can be detected.
Great. Thanks, Daniel. Thanks, David. Next up is Adrian Walker. So Adrian's question is, what is Passive House Institute's reaction to the system?
Thank you. I'll let Bernard take this one.
Right. So I've been in touch with Dr. Wolfgang, and his first reaction was that he welcomed it, but he absolutely correctly said this cannot replace the pressure test. We were then invited to submit a paper, and to I'm sure along with many thousands of other people, to speak, to have 5 minutes at the upcoming conference in March. We did that. We got a very kind reply, but unfortunately, we weren't selected this time round. So the response so far has been neutral. It's something which has been welcomed, but nothing more than that at this early stage.
Excellent, thank you. Next is Kay Kaufman. Kay, I think that this may have been answered already, but if you have a follow-up, please share it.
Thank you. The specific question was answered. I think, like many people, trying to figure out how this new technology or this technology applies to what we specifically do, and trying to explore those limitations. I was curious if, to some degree, what the cost is, or if a rental sort of application had been considered in terms of accessing the technology and trying to test it for our specific applications.
Yes, I think it's really sort of a commercial question, and we at the moment export over 90% of what we produce, and this is one of 28 of different technologies that we have invented, developed, manufacture, and export. And we export to 120 different countries through almost 200 distributors. And our policy is to sell our technology. If people in various countries want to commercialize this in a different way, then obviously that can be considered. But essentially what we find is it's rather like a gardener likes his own tools. And when you start sharing tools, things are not so good. These are precision instruments, and these are instruments which are robust, which can be used in extreme conditions. But they are instruments that have to be cared for. They are instruments that have to be calibrated. And they are instruments which are producing critical data for you to use. And therefore, I think the cost, when you consider the amount of money that this will save people, is certainly manageable. I'm speaking to you as a former property developer, as a person who's known what it is to have spent millions of pounds in developing property, which then fails the pressure test. As a developer who's had to face up to paying out penalty clauses for late delivery. As a property developer who's had to deconstruct parts of a development in order to find the leaks. And as a property developer who suffered the consequences of poor materials, poor workmanship, and failure. We've developed an instrument to provide you with certainty of outcome. You can use it in a factory. When you make a window, you can make sure that each pane of glass is airtight because you don't require any form of pressurization. You can check the doors. Depending on whether you have traditional construction or modern methods of construction, and where there's modern methods of volumetric, modular, or panelized, you can check for airtightness at every stage of your build program. And if you don't believe that this instrument works, you can check it against what you already have. So you can use the instrument, you could achieve an air permeability value, you can read it, you know what it is. And as soon as you've done that, you can conduct a door fan blower test, and you will know straight away that our instrument works.
Sorry, I'm just going to add to that. Yeah. I know we don't have much time, but I've just been told by our commercial team, of course, we offer, we can provide quotations ourselves, but of course we work with Source 2050 as our exclusive distributor in the US. So if you're interested in sort of different ways of doing it, we sell the technology, but commercially speaking, that conversation can certainly be had. And also, as Bernard says, if you're interested in kind of seeing a degree of proof of how the technology would work in a certain situation, then we can also provide demos through Source 2050.
So next up is Sandra Lester.
Hi there. Thanks for a great presentation. I really see the value in being able to guide the contractor in specific places where they're missing the airtightness. What I was wondering is the application for large buildings and how it could be used for building envelope module testing and then commissioning of building envelopes.
Yes, I think Daniel's already touched on large buildings. We are at the development stage, and large buildings are important to us, and we need to address this. We need to develop some form of technology, whether it is a drone, whether it's using telescopic poles or some other method. But we certainly need to be able to position the transmitter correctly so that large buildings can be included in this process. And that is something which is currently not possible, but something which is a challenge that we are working on at the moment, because obviously we are interested in achieving this. When you look at modular you can start off with the various precision-made components being assembled in a factory. and then the modular units are being taken to site. Certainly, you can do all the airtightness checks before that modular unit leaves the factory. I do understand that in some cases, modular units can get stressed. They can get stressed when being transported. They can be stressed when they're being lowered onto craned and what have you. And then once they're on site, they have to be joined up with all the other modular bits and pieces. And so you probably want to do various tests again. What this enables you to do, it takes about 30 minutes to train an operator. And it's quite a sort of important health and safety issue here, because provided that the operator is able to access to conduct the airtightness test, he can do that without disrupting the work. It's not, for example, an issue like hot welding. When somebody starts doing some sort of hot welding, then no one else can be anywhere near him because of health and safety regulations. And that's very disruptive to the rest of the execution of the build program. So what you've got is an instrument that you can use as frequently as you wish. And it may be that, at the end of the day, when everybody's left off site or wherever it is, that there's one individual or a couple of individuals who remain there and who conduct the airtightness checks. And so at the end of every day, the foreman or the clerk or the site manager or whoever you make responsible for doing this is constantly checking for airtightness. And whether that is the envelope or whether that's compartments within the modules, it will work. You've just got to ensure that the receiver and the transmitter are each side of the barrier that you are testing for airtightness. Does that help you, Sandra?
Yeah, that helps a bit. Thank you.
Yeah. Okay. Thank you.
Great. Thank you, Sandra. I want to give a big thank you to Coltraco for today's presentation and for bringing this brand new technology for us. It's brand new to Passive House world to our community, and for Coltraco's support of Passive House Accelerator. And a big thank you to everybody for joining us for this presentation and for all the really great questions and dialogue that we've had today. I think with that, Bernard and Daniel, would you like to say a final thought before we close up?
Well, first of all, thank you. Thank you to you, Zach, and also thank you to John Knapp of Source 2050. I was privileged when I got in touch with John, and I saw what he was trying to achieve. I immediately saw what John's intentions were. And John is out to achieve excellence. And that, to me, is what Passive House is all about. It's an international concept. It's a group of people that have come together from every corner of the world because they want to make buildings better. Now, I've been a property developer. I spent over 20 years developing property. It wasn't a great success. And it was very difficult. And I think less than 0.5% of the projects that I was involved in came in on budget, on time, and was satisfactory. But one of the great differentials of Passive House is you set out to build an airtight building, you will build a good quality building. And it really marks the building out for quality. And this instrument is all about helping you to achieve that excellence. It's about making you better than your competitors, faster than your competitors, and cheaper than your competitors. It's about giving you the confidence that every stage of that project, be it a new build or a retrofit, you're going to pass. You're going to achieve the standard of airtightness that's expected of you as a Passive House individual. Thank you.
what more can I add to that? I just want to say thank you, everybody, for joining. Thank you, Bernard, for presenting with me. Thank you to Source 2050, and thank you so much for some of the questions, really interesting ones, some of them quite high level scientifically. So I hope I answered them well enough for you, and send more in by email, and we'll do our best to get back to you.